Hello there, and a very warm welcome to this quiet little sanctuary we've built here. A soft-lit corner of the universe just for you. The world outside is growing quiet. The day has folded itself away, and the moon has taken its post in the ink-black sky. Perhaps you can hear the distant hum of the city settling into slumber, or the gentle whisper of the wind through the leaves. Whatever sounds surround you, let them be a part of this moment. I'm so glad you found your way here, whether you're nestled deep in your blankets, curled up on a favorite old couch, or simply seeking a moment of peace to quiet the spinning compass of your mind. You have come to the right place. This is the Sleepy Scientist, where the grand, complex wonders of science trade their lab coats for pajamas, where curiosity speaks in hushed tones, and where we explore the universe not with a bang, but with a whisper. Tonight, we are embarking on a very special voyage. We will be turning the pages of a book written not with ink, but with neurons and starlight. We're going to journey deep into the most mysterious territory we know, the landscape of the dreaming mind. It's a world filled with the strange, beautiful stories your brain tells itself while you're lost to the world. A place of brainwaves that ripple like abstract art, and a few discoveries so surprising they might just change the way you think about the simple act of falling asleep. Now, I do hope this exploration isn't so fascinating that it keeps your eyes open, but if it does, well, at least you'll be learning something extraordinary, a fair trade, I'd say, before we truly begin our descent. If you find comfort in these slow, scientific lullabies and would like to help this sleepy little channel grow, I would be ever so grateful if you'd consider tapping the like button, subscribing, or even just leaving a quiet comment below. Tell me where in the world you're listening from, and what time it is in your corner of the night. It's a lovely thought, knowing we are all connected in this shared stillness. Alright, let the tension leave your shoulders. Take a slow, deep breath in, and let it go with a gentle sigh. Let's begin our quiet voyage into the grand theater of the dreaming mind. What, exactly, is a dream? It sounds like such a simple, straightforward question, doesn't it? But trying to define a dream is a bit like trying to bottle a cloud, or capture the scent of rain on dry earth. You can feel it. You can experience its presence. But the moment you try to grasp it, it shifts, changes, and slips through your fingers, leaving only a trace of moisture behind. At its most fundamental level, a dream is a cascade of thoughts, images, emotions, and sensations that your mind spontaneously generates while you are asleep. It's the universe's original streaming service, beamed directly from your own personal production studio, located somewhere behind your eyes. The programming is eclectic. Sometimes it's a high-stakes drama, sometimes a slapstick comedy, occasionally it's a heart-pounding thriller, and more often than not, it's a completely nonsensical art film that critics would call brave. And yet, for all their surreal and bizarre qualities, dreams possess an almost unshakable sense of reality while they are happening. You might find yourself flying over a city made of glass, arguing about philosophy with a walrus in a tuxedo, or suddenly remembering you have a final exam for a class you never attended. despite having graduated a decade ago. And during the dream, you are utterly convinced that all of it, the flying, the walrus, the impending academic doom, makes perfect, logical sense. But why? Why does your brain, this incredible organ of logic and reason, dedicate hours each night to producing these elaborate, unscripted fantasies? To understand the modern view, it helps to take a quiet walk through the past. Way back, in the cradle of civilization, in ancient Mesopotamia, dreams weren't seen as brain chatter. They were considered divine communiques, messages sent from the gods. Kings and commoners alike believed their dreams held prophecies, warnings, or guidance. The Egyptians took this even further, establishing professional dream interpreters. Think of them as ancient, sleepy oracles. If you dreamt of a cat, a flood, or a flying crocodile, there was likely a scribe with a papyrus scroll ready to tell you what it all meant. Fast forward to ancient Greece, where the great philosopher Aristotle began to shift the conversation. He was one of the first to bravely suggest that dreams might not come from the heavens, but from within the dreamer. He proposed they were echoes of the day's sensory experiences, fragments of our own bodies and minds bubbling up in the quiet of the night. It was a radical idea, but the notion that dreams held special, hidden meaning persisted for centuries. Then came the 19th and early 20th centuries, and with them, the man who made dreams fashionable again, Sigmund Freud, with his iconic couch and piercing gaze. Freud declared dreams to be the royal roads to the unconscious. He believed they were a coded language, a stage where our hidden desires, repressed fears, and forbidden wishes could play out in disguise. According to Freud, every dream had a manifest content, the strange story you remember, and a latent content, the deep, true meaning hidden beneath. It was all very dramatic, deeply influential, and, as we now know, probably not entirely accurate. But it did spark a revolution in how we thought about our inner lives. Carl Jung, once Freud's protege, took a slightly different, more mystical path. He believed that dreams didn't just connect us to our personal unconscious, but to a shared human experience, a vast reservoir of symbols and stories he called the collective unconscious. For Jung, symbols in dreams like the wise old man, the shadow, or the great mother were archetypes, universal patterns with deep meaning that transcended our individual life stories. But this is where science gently taps philosophy on the shoulder and says, "Excuse me, mind if I take a look under the hood?" Modern neuroscience takes a much more grounded, biological approach. Instead of assuming your dream about your third-grade teacher is a coded message about your mother, sorry, Freud, researchers now study the brain itself. They look at its electrical activity, its chemical fluctuations, and its blood flow during sleep. And what they've found is that dreams are intimately tied to specific stages of sleep, most notably a stage called REM sleep. REM stands for rapid eye movement, and during this stage, your brain is astonishingly active, sometimes almost as active as when you are fully awake. Your eyes dart back and forth beneath your eyelids. Your heart rate and breathing become more irregular, and your body enters a state of temporary paralysis, a clever safety feature we'll talk more about later. This is the stage that produces the most vivid, narrative-driven, and often bizarre dreams, the ones with talking giraffes and dramatic plot twists. Those are almost always a courtesy of REM. And so, the modern definition of a dream is a beautiful fusion of all these ideas. It is a subjective experience, a story woven from the threads of our memories, emotions, and daily lives. As Aristotle and Freud suggested, it may tap into universal human themes, as Jung believed, but fundamentally, it is a biological phenomenon, a product of the sleeping brain's unique neurochemical state. It's the mind's nightly art project, messy, mysterious, and profoundly human. We often think of sleep as a single, monolithic state, like flipping a switch from on to off, and pressing pause on consciousness for 8 hours. But beneath the calm surface of your closed eyelids, your brain is not idle. It is conducting a complex, well-orchestrated performance, a symphony in several movements. Scientists even call this intricate structure sleep architecture, which makes it sound very grand and perhaps a little expensive. So, let's take a quiet, moonlit stroll through the blueprint of a night's sleep. No hard hats required. Your journey through the night isn't a straight line down into deep sleep and back up. Instead, you cycle through different stages, each with its own unique purpose and brainwave pattern. The entire cycle repeats roughly every 90 minutes. Like a favorite playlist, your brain keeps on a loop, though with fewer commercials and slightly more drawl. Sleep is broadly divided into two major categories: REM sleep, our dream factory, and non-REM sleep. And NREM sleep itself is further broken down into 3 stages, helpfully labeled N1, N2, and N3. They might sound like droids from a science fiction movie, but they are actually just different depths of unconsciousness. Stage N1, the gentle descent. This is the very first, lightest stage of sleep. It's that magical, fleeting moment when you are just beginning to drift off. You're teetering on the edge of consciousness, still vaguely aware of the world around you, but your thoughts have begun to wander and lose their sharp edges. Your brainwaves start to slow down from the busy, active alpha waves of relaxation into the slower, more rhythmic theta waves. This is the stage where you might experience a hypnic jerk, that sudden twitch or sensation of falling that jolts you awake. Don't worry, it's not your soul trying to make a quick escape. It's just your nervous system having a tiny glitch as it transitions from wakeful control to sleepy relaxation. If someone were to wake you during N1, you might sit up and insist, "I wasn't asleep at all." And you'd be half right. Stage N2, light sleep, the quiet harbor. Now you're sinking a little deeper, leaving the shore of wakefulness behind. In stage N2, your body temperature begins to drop. Your heartbeat and breathing slow down to a steady rhythm, and your eye movements stop. You are now officially asleep, no longer taking calls from the outside world. This stage is the workhorse of sleep. You'll spend about half your total sleep time here. It's characterized by 2 fascinating brainwave phenomena: sleep spindles and K-complexes. These names might sound like something from a fantasy novel, but they are actually the brain's gatekeepers. Sleep spindles are short, rapid bursts of brain activity thought to be involved in memory consolidation, while K-complexes are large, slow waves that are believed to protect your sleep by suppressing outside stimuli. That car horn that just blared outside. Your brain likely just released a K-complex to say, "Sure, nothing to see here," and keep you peacefully asleep. Stage 3. Deep sleep. The Great Restoration. Welcome to the deep end. Stage 3, also known as slow wave sleep, is the most restorative and physically vital phase of sleep. This is the deep clean cycle for your brain's dishwasher. The time when the body does its most important repair work. In 3, your brain produces large, slow, rolling delta waves. These are the slowest of all brain waves, and their presence indicates you are in a very deep state of unconsciousness. During this time, your body repairs and regrows tissues, builds bone and muscle, and strengthens the immune system. For growing children, this is when a significant amount of growth hormone is released. For adults, while we don't get any taller, unfortunately, we still reap the immense benefits of this cellular spring cleaning. It is incredibly difficult to wake someone from a 3 deep sleep. If you do manage it, they will likely be groggy, disoriented, and profoundly confused for several minutes, a state known as sleep inertia. It's like being yanked out of a perfectly warm, comforting bath by a foghorn. Dreaming can occur here, but it's usually more like abstract thought fragments or fleeting emotions, rather than a coherent story. The real movie magic happens next. REM sleep, the dream factory. After a journey through the depths of an REM, your brain ascends back up, not to wakefulness, but into the vibrant, paradoxical world of REM sleep. This is the mysterious realm where your brain lights up like a city at night. Your muscles go completely limp, and your eyes dart back and forth beneath their closed lids, as if watching an invisible, high-speed tennis match. REM is where the vast majority of your most vivid, memorable, and bizarre dreams unfold. It is the brain's sandbox, a playground for strange stories, emotional rehearsals, and the occasional celebrity cameo. But REM isn't just for entertainment. It plays a crucial role in memory consolidation, especially for procedural and emotional memories, emotional regulation, and fostering creativity. Some researchers believe that REM sleep is what helps you sleep on it, allowing you to find novel solutions to problems you were stuck on during the day. The paradox of REM sleep is this: your brain is incredibly active, but your body is almost completely still. You experience a temporary unprotective paralysis called rematonia, which prevents you from physically acting out your dreams. It's a brilliant safety feature. Your brain says, "Let's imagine you're a superhero flying through canyons," and your body wisely responds, "Cool, I'll just lay here completely motionless and let you do your thing." The full sleep cycle. So, putting it all together, you start by dipping into light sleep on 1, drift into the deeper harbor of an 2, sink into the restorative depths of an 3, and then bubble back up into the cinematic world of REM. This entire cycle takes about 90 to 110 minutes, and you repeat it 4 to 6 times a night. However, the architecture of the night changes as you go. In the first half of the night, You spend more time in restorative deep sleep, and 3. In the second half, the REM stages get progressively longer, and the deep sleep stages get shorter. This is why your longest, weirdest, and most memorable dreams often happen in the hours just before you wake up. Your brain schedules the heavy-duty maintenance work first, and then settles in for a long night of entertainment and emotional processing. Understanding this rhythm is the first step to becoming a true connoisseur of your own sleep. It is the question that has echoed through the halls of human thought for millennia, a question whispered by philosophers under starry skies, pondered by mystics in quiet temples, and now meticulously investigated by scientists in sterile labs. Why do we dream? Despite all our advanced technology and late-night musings, the definitive answer remains tantalizingly out of reach. Dreams are one of the last great, mysterious frontiers of the human experience. Let's open the doors to the midnight library of theories and browse the different explanations that science has offered so far. Theory 1. The Memory Librarian. Dreams for memory consolidation. One of the most widely supported theories is that dreams play a crucial role in managing our memories. Think of your brain as a massive, bustling library. During the day, it receives an avalanche of new books, faces, facts, skills, conversations, disappointments, the lyrics to that song stuck in your head, the taste of your lunch. By the end of the day, the front desk is piled high with unsorted information. It's a mess. At night, especially during REM and into sleep, the memory librarians get to work. According to the memory consolidation theory, sleep is when your brain sifts through this pile. It decides which memories are important enough to be catalogued and placed on the long-term shelves, which are trivial and can be sent to the recycling bin, and, most interestingly, which new books should be cross-referenced with the old ones already in the collection. Dreams, in this view, are the side effect or perhaps even the process itself of this nightly filing system in action. You are experiencing the librarians at work, pulling books off shelves, comparing pages, and creating new, sometimes strange, connections. This is why students who are studying for a big exam or learning a new instrument often report an increase in REM sleep and may even dream about the very material they've been learning. It's your brain's way of saying, "Okay, let's rehearse this one more time." Theory 2. The Emotional Alchemist. Dreams for emotional regulation. Life is an emotionally messy business. We experience joy, fear, heartbreak, and frustration. If we carried the full weight of every emotion with us all the time, we'd be exhausted. This is where the emotional alchemy of dreaming might come in. During REM sleep, a fascinating neurochemical event occurs. Your brain's emotional centers, particularly the amygdala, are highly active, but the brain's stress-related chemicals, like norepinephrine, are almost completely shut off. Neuroscientist Matthew Walker describes this state as overnight therapy. It allows your brain to reprocess emotionally charged memories from the day, but without the baggage of the actual stress response. It's like watching a scary movie with the sound turned off. The experience is still there, but it's sharp. Painful edges are softened. This process can help strip the emotion from the memory, allowing you to learn from difficult experiences without being perpetually haunted by them. That dream where you calmly discussed your recent breakup with your ex while riding a slow-moving elephant. That might have been your brain's therapeutic process in action, saying, "See, we can look at this now. It doesn't have to hurt so much." Theory 3. The Threat Simulator. Dreams for Survival Rehearsal. This theory, proposed by philosopher Auntie Revan, takes a more primal, evolutionary perspective. It suggests that dreaming is an ancient biological defense mechanism, a kind of virtual reality simulator for threats, for our ancestors living in a world full of predators and peril. The ability to rehearse escape scenarios would have been a major survival advantage. According to this view, dreams are a safe space to practice your fight-or-flight responses, being chased, falling, being attacked, being lost, or finding yourself in a high-stakes social situation you're unprepared for. These common nightmare themes might be your brain running late-night fire drills. It's your primal instincts doing a bit of training, keeping your survival skills sharp. This might explain why anxiety dreams are so common. It's not necessarily that you're anxious. It's that your brain is keeping the anxiety circuits well-oiled, just in case. Theory 4. The Creative Muse. Dreams for problem-solving and creativity. Have you ever gone to bed completely stuck on a problem, only to wake up with a sudden, elegant solution in your mind? That's not magic. That's your dreaming brain working the night shift, freed from the rigid constraints of logic and linear thinking that govern our waking hours. The dreaming mind can make connections that our conscious mind would dismiss as illogical. It throws ideas together in strange combinations, creating a fertile ground for insight and innovation. History is filled with stories of this. Paul McCartney famously claimed the entire melody for Yesterday came to him in a dream. Mary Shelley's Frankenstein was born from a waking dream she had one stormy night. The chemist August Kekulé discovered the ring structure of the benzene molecule after dreaming of a snake biting its own tail. Dreams are the mind's playground, where it can experiment without fear of failure, leading to moments of profound creativity. Theory 5. The Accidental Artist. The Activation Synthesis Hypothesis. This is one of the more mechanical, bottom-up explanations proposed by Alan Hobson and Robert McCarley. This theory suggests that dreams don't really have a purpose at all. Instead, they are simply the brain's attempt to make sense of random electrical impulses that originate in the brainstem, specifically the pons, during REM sleep. These random signals, the activation, are sent up to the cortex, which then does its best to weave them into a coherent story, the synthesis. In this view, the talking duck, the sudden scene change, the appearance of your third-grade teacher on a pirate ship, these aren't symbolic messages. They're just your brain storytelling in chief doing its best to create a narrative out of chaotic, nonsensical input. The dream itself has no inherent meaning. The meaning is what we impose on it after we wake up. It's like seeing shapes in the clouds. The cloud isn't trying to be a dragon. Our brain just sees one. So, which theory is correct? The beautiful truth is, they all might be. Dreaming is likely not a single-purpose tool, but a multifunctional Swiss Army knife of the mind. It's a space where we sort memories, regulate emotions, rehearse for threats, and solve problems, all while our brain tries to tell a story about the random neural firings that make it all happen. It's a process that is simultaneously meaningful and accidental, purposeful and chaotic, and that's the strange, profound beauty of it. Have you ever wondered what part of your brain is responsible for that dream, where you were trying to take an exam in a swimming pool filled with marshmallows? The answer lies not in one single spot, but in a delicate nocturnal dance. A dance between several key regions, each with its own special role in the theater of the dreaming mind. Let's step quietly into the brain's control room. It's dimly lit here and the usual buzzing of the day has quieted to a low hum. First, let's look at the prefrontal cortex. This region sits right behind your forehead. By day, it's the responsible adult in the room. It's your logical thinker, your planner, the voice of reason. But when you fall into REM sleep, this part of your brain takes a little nap of its own. It quiets down, it steps aside, and it lets the rest of the brain take the stage. The result is dreams that are illogical and often completely bonkers. Without the prefrontal cortex overseeing things, your inner editor has gone home, and the art department is running wild. Meanwhile, other areas are lighting up with activity. Look there, deep inside the brain. That's the amygdala. This small almond-shaped region is the heart of your emotional world. During REM sleep, it becomes particularly active. The amygdala is responsible for processing emotions, especially fear, anger, and pleasure. It's the part of the brain that makes dreams feel so important, so intense, even when the plot makes zero sense. Now let's turn to the hippocampus. This is your brain's librarian, responsible for creating and organizing memories. It's closely linked with dreaming too. The hippocampus helps retrieve the raw materials for your dreams. The restaurant you passed earlier, the song stuck in your head, your second-grade teacher. But the hippocampus isn't fully online during REM sleep, which may be why dream memories are so disjointed and so hard to recall. The filing cabinet is open but the lights are dim. And what about the senses? That's the job of the thalamus. The thalamus is the brain's sensory gatekeeper. During sleep it shuts the gates to most outside sensations so you can stay asleep. But during REM it opens an inner gate. It allows the signals originating from the brainstem to travel up to the cortex, creating the vivid sights and sounds of your dream world. Finally, we have the brainstem itself, specifically a part called the pons. This is the engine room, the spark that initiates REM sleep. It sends out waves of electrical activity that kickstart the whole dream process. And it also sends a signal down the spinal cord to temporarily paralyze your muscles. That helpful paralysis is called rematonia. It's what keeps you safe and still while your dream self is off flying or fighting dragons. So you see, dreaming isn't chaos. It's a carefully coordinated event. A unique state created by a specific cast of brain regions, all playing their part in the quiet theater of the night. Imagine you're dreaming. You're walking through a vast library made entirely of marshmallows. The librarian is a talking raccoon in spectacles. Everything feels real. Then suddenly a quiet thought drifts through your mind. Wait a minute. This is a dream. And just like that, the whole experience shifts. You are aware. You are lucid. Lucid dreaming is one of the most fascinating quirks of human consciousness. It's that moment in a dream when you realize you are dreaming. And sometimes you can even control what happens next. You might choose to fly, or speak to a long-lost friend. Or more realistically, spend the entire dream just trying to walk through a wall. Scientists define lucid dreaming as a hybrid state of consciousness, a blend of waking awareness and REM sleep. Your brain is asleep, but a part of you has woken up inside the dream. What's happening in the brain at that moment? Remember the prefrontal cortex, the logical part that usually takes a nap. In lucid dreams, parts of it reactivate. The regions associated with self-awareness and reflection come back online. It's like your mind quietly opens one eye and says, "Oh, I see what's happening here." Some people stumble into lucid dreams by accident, but others actively train themselves. One technique is called the mild technique. It involves setting the intention as you fall asleep to remember that you are dreaming. Repeating a quiet phrase to yourself like, "Next time I'm dreaming, I will know I'm dreaming." It's like planting a little seed of awareness in the garden of your mind. Another common practice is the reality check. Throughout your day you can pause and ask yourself, "Am I dreaming?" You can try to push a finger gently through your other palm, or look at a clock or a piece of text, look away, and then look back. In a dream, these reality tests often fail in strange ways. Your finger might pass through your hand. The text might change. By making this a habit, when you're awake you increase the chance you'll do it while you're asleep. And in that moment, you might just become lucid. For some, lucid dreaming is simply for fun. A chance to explore impossible worlds. For others, it's therapeutic. People who have frequent nightmares can use lucidity to confront their fears, to turn and face the monster and say, "This is my dream." It can also be a playground for creativity, a space to solve problems or explore new ideas. Still, lucid dreaming isn't something everyone experiences, and that's perfectly okay. The goal of sleep is always rest, but it is a beautiful reminder of how flexible and how mysterious our consciousness truly is. Everyone loves a good dream. Floating through clouds or visiting impossible worlds. But not all dreams are made of whimsy. Sometimes your sleeping mind turns the lights down and delivers something far less comforting. A nightmare. Nightmares are the emotional thunderstorms of our dream life. They are vivid, disturbing dreams that typically happen during REM sleep. The big difference is the emotional tone. A nightmare ramps up the intensity, triggering fear, anxiety, or deep sadness. Most people experience nightmares from time to time. They are a normal part of processing difficult emotions. But not all scary sleep experiences are nightmares. There's another category called night terrors. Night terrors are a different beast altogether. They usually happen during deep non-REM sleep early in the night. Unlike a nightmare, a night terror is not a story. It's more like a sudden storm of panic erupting from the brain. A person might sit up, scream, or thrash around, but they are not fully awake, and they will usually have no memory of it the next morning. Night terrors are much more common in children, who almost always outgrow them. They are not technically dreams at all, more like a misfire between sleep states. Then there is the eerie cousin of these experiences: sleep paralysis. This happens when your mind wakes up before your body does. You are conscious, but you find you cannot move. This is because the natural muscle paralysis of REM sleep has lingered for a few moments too long. This state can sometimes be accompanied by hallucinations, a feeling of pressure, or seeing a shadow in the room. For centuries people blamed these experiences on demons or spirits. But today we know it's a natural, harmless glitch in the sleep system. It usually passes within a minute or two. So why does the brain have such a talent for scaring itself? One theory is that fear is a powerful teacher. Negative emotions help cement memories of potential dangers, and so our brains may run these frightening simulations to help us prepare for real-world threats. A kind of psychological fire drill. If you have a nightmare or a frightening sleep experience, be gentle with yourself. It may be your brain's way of trying to work something out, a sign that it is processing and protecting you even in the dark. And remember, you are safe in your bed. It was only a dream. We often think of sleep as a time to escape the world. But our dreams don't always get the memo. They don't politely ask if now is a good time to unpack unresolved emotions. They just barge in. It turns out that dreams and our mental health are closely linked. Like two dancers moving through the night, each one influences the other. When you're stressed, anxious, or emotionally overwhelmed, your dreams tend to get louder. They become more vivid, more chaotic. You might dream about being chased or lost or unprepared. These dreams can mirror the emotional turbulence of your waking life, an abstract art version of your inner state. People with depression, for example, often report more negative dream content. Their dreams might feel heavy or repetitive or emotionally flat. Anxiety disorders, on the other hand, tend to show up as dreams filled with threat or pressure. The connection also runs deeper than just the content. The very structure of dreams can shift. People going through intense stress or trauma often have more fragmented, jarring dreams. It's as if the brain is trying to process too much too quickly. In post-traumatic stress disorder or PTSD, nightmares are a hallmark symptom. The brain's usual system for processing emotional memories seems to break down. Instead of soothing the wound, the dream repeats it like a stuck record. This is why therapies that focus on dreaming can be so powerful. By mentally rewriting a nightmare while awake, people can gradually change the dream story and reduce its emotional power. It's like giving the brain a new play to perform. one with less terror and more resolution. Our dreams can also be a window into our emotional truths. They can reveal fears we haven't voiced or hopes we've kept hidden. Not every dream needs to be analyzed. Sometimes a floating platypus in a bow tie is just a floating platypus in a bow tie. But when a dream does something deeper, it's worth noticing. Because your dreaming mind isn't separate from you, it's a part of you. A nighttime version of yourself trying in its own strange language to be understood. So if you are going through a hard time, and your dreams are darker or stranger, be gentle with yourself. Your mind is still processing, still working even in the dark. You've probably seen it before. A dog sleeping soundly on the floor, paws twitching, tail flicking. Maybe even letting out a muffled bark or two. Or a cat stretched out on a windowsill, whiskers twitching. If you've ever wondered whether animals dream, the answer is almost certainly yes. Of course, they can't tell us about it. But science has given us some very strong clues. Let's start with the basics. Almost all mammals and many birds experience REM sleep. The very same stage of sleep where humans do most of their dreaming. And in animals, this stage looks very familiar. The twitching, the flickering eyes, the occasional sleep vocalization. It's like a silent movie playing behind their eyelids. Brain scans offer even stronger evidence. In a famous study, researchers recorded the brain activity of rats as they ran through a maze. Later, while the rats were in REM sleep, the researchers observed the exact same patterns of brain activity. The rats were replaying the maze in their minds. It was as if they were dreaming about their day. Birds do it too. Zebra finches, for example, have been shown to rehearse their songs in their sleep. Their brains replay the neural patterns of singing note for note. Dream karaoke, if you will. And it's not just mammals and birds. Recent studies suggest that even some reptiles and octopuses have a sleep state that resembles REM. Dreaming might be a much older and more widespread trait than we ever imagined. So what are they dreaming about? That is the big mystery. But we can make some reasonable guesses. They probably dream about the things that matter in their lives. Hunting, playing, exploring, and social bonding. And for our pets, it's very likely that they dream about us. You are a central part of your dog's or cat's life. It only makes sense that you would appear in their dreams. Dreaming in animals also raises fascinating questions. It suggests that we share a deep inner world with the creatures around us. A world of instinct and memory and story. So the next time you see your pet twitching in their sleep, let them be. They are on a voyage of their own. Through inner landscapes you will never see. And as you drift off tonight, you might smile knowing you are not the only one dreaming. For most of human history, dreams have been private. A world seen by one person alone. Like whispers in a locked room. But now scientists are beginning to pick the lock. Welcome to the strange and slightly sci-fi frontier of dream science, where technology and neuroscience are combining in remarkable ways. For starters, the field of targeted dream incubation is growing rapidly. The idea is that if you give the brain a gentle nudge during sleep, you might be able to influence the content of dreams. Experiments have shown that playing specific sounds, or releasing certain scents can trigger related dream imagery. It's not mind control. It's more like mental gardening, planting a seed and seeing what grows. Imagine a future where this could be used for learning or for creativity. Then there is the fantasy of dream recording. The idea of watching a dream back like a movie. We are nowhere near that yet. But researchers are starting to decode basic visual content from the brain during sleep using fMRI and AI. The results are still fuzzy and vague, like watching a dream through frosted glass. But the door has been cracked open. Of course, this raises very big and very important ethical questions. Dreams are our last private sanctuary. What happens when technology can enter that space? This is why conversations about neurorights have begun. The right to mental privacy and freedom of thought. Because while it might be fun to share your dreams, there is something sacred about the fact that they are yours and yours alone. The future also holds great promise for healing. Imagine personalized dream therapy for people with PTSD. Or using guided dreams to help children with anxiety. The possibilities are vast. But for all this dazzling technology, it's reassuring to remember something simple. Dreaming at its core doesn't require any gadgets. Your brain already has everything it needs. To remember, to process, to create, and to wonder. The future of dream science may bring new tools and new therapies. But it will likely never fully replace the simple wonder of waking up with a strange story in your head. The mystery will always remain. And so, here we are, at the quiet edge of our long journey. We have glided back from the strange and beautiful world of dreams. A landscape painted with the colors of memory and emotion. We've tiptoed through the intricate architecture of sleep, wandered the echoing halls of our own minds, and peeked, just a little, into the starlit future of dream science. What we know so far is astonishing, but what we don't know remains even more wondrous. For all the brain scans and neural maps, dreams still hold their secrets close. They slip through the fine mesh of our scientific nets, reminding us that the mind is not just a machine to be decoded, but a universe to be explored. It is part science, part poetry, and part soul. So as you finally drift off tonight, into the soft, deep current of sleep, let go. Whether your brain takes you on an epic adventure to a city in the clouds, a quiet walk down a forgotten lane of your childhood, or something so beautifully bizarre it defies all logic, just let it happen. You don't need to understand every detail. You just need to rest. Your brain, your very own sleepy scientist, knows what it's doing. And if this long conversation has made you just a little too fascinated to fall asleep right away, well, I do apologize, but I hope it has been a worthy trade for a little bit of wonder. Before we part ways for the night, if you've enjoyed this slow, deep dive through the sleeping brain, I would be truly grateful if you gave this video a gentle thumbs up, subscribe to the Sleepy Scientist, or left a quiet comment below. I truly do love reading where in the world this little cloud of calm has drifted to. Until next time, sleep well, dream freely, and remember, your mind is still telling stories, even in the quiet dark. Good night.